Hello, everybody. This is Professor Eskandari. We are going to start our class, BUSB-145. And the first thing I would like to do is review some basic algebra because those are the skills we need to be able to be successful in this class. I'm gonna upload this in Moodle, so you can have access to it. And please make sure you watch this video before our first session, which is the 28th of April. Okay, so let's see what's happening here. We have these three what we call expressions. Remember, there's a difference between expression and equation. Expression is made up of variables and numbers without any equal sign, but equation obviously will have an equal sign. So let's do the first one. It says add all three. So here we go. We have 3x minus 4 plus the second one, x plus 2, plus the third one, 2 minus 3x squared. Now, if you remember, we can combine like terms. Now, what are like terms? Like terms are quantities that have the same variable in them and the same power on those variables. Now, in this expression, what is our variable? Well, variable is obviously x. And those are, we usually use the letters from the English alphabet and sometimes from the Greek alphabet, like alpha, beta, gamma, so forth. But for the purposes of this class, most of the time we will use x, y, z, a, b, so forth, or t. So these are your variables, the x's. And obviously, these are the numbers. Now, if a number, well, let's simplify this and we'll explain a little bit more. All right, so those are the like terms. Like terms are quantities with the same variable and the same power or exponent on those variables. So notice I have 3x's here to the power of 1. Remember, if the power is not shown, it's automatically 1. It's not 0. 3x's to the power of 1, 1x, and then I have an x here, but it's to the power of 2. So I cannot combine these guys with this one. So I can only combine these two. So I have 3x plus 1x. So I got 3 apples plus 1 apple. That gives me 4 apples, right? And then I have the negative 3x squared. I'm going to put it in the front like this. And then what's left? All the numbers, or as we call them, constants. Negative 4 plus 2, that's negative 2. Negative 2 plus 2, they cancel each other, so it's 0. So that's it. So we got this, we got this, we got this, 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 this. So we combine all the terms. So this is the results of 1a. Okay, adding all three. Now, there was a reason I put it in this form. Notice the higher exponent is on the left side. We call this the descending order. Descending, that means going down. And the highest exponent is on the left, then the next highest, and so forth if you have more. Now, 4 and negative 3 are considered coefficients. If a number is attached to a variable, then we call that a coefficient. Now, if your coefficient is attached to a variable with the highest exponent, then we call that the leading coefficient. So your negative 3 is called the leading coefficient. So negative 3 is called leading coefficient. I hope I spelled it right. And this, the highest power in your expression, is called a degree. So degree, in this case, is 2, the highest exponent. All right, we'll get to some other ones. All right. Part B, subtract A from C. So you got to be careful in this. It says A from C. So which expression comes first? C comes first because you're taking away A from it. So you're going to write 2 minus 3x squared minus, and you got to be careful here because if you notice, A has two parts or two terms. So you got to put a parentheses around there because this negative sign belongs to the whole thing. So now we are taking away A from C. This is my expression C. This is my expression A. I'm subtracting A from C. That's the subtraction. So technically we have a -1 here. We just don't show the 1. And now we're going to do one of the most famous properties in all of algebra. That is distribution. So there's multiplication here, so we distribute. So I'm not touching the 2 minus 3x squared. So what's a negative times a positive? It's a negative 3x. What's a negative times a negative? That's positive. 1 times 4 is 4. Okay, so we distributed, and once you distribute, you can forget about the grouping symbols, in this case, the parentheses. All right, so then combine like terms. There is no x squared anywhere, so I'm going to keep that as it is. And there's no other x to the power of 1. I'm going to keep that as it is. And I have a +2 and a +4. That gives me +6. So there you go. We are done. Okay. So this is again in descending order. The degree happens to be 2 again. That's the highest exponent. The leading coefficient, which is the number attached to the variable with the highest exponent, that's -3. And then we have this number where there is no variable attached to it. And if the number is by itself, we call it a constant. So 6 is a constant. Okay, let's go to part C. Multiply A and B. So I'm going to write it over here. So 1C, A and B. So we have 3x minus 4. I'm going to put that in the parentheses times B, which is x plus 2. Okay, so 3x minus 4 times B, which is x plus 2. Okay, so if you guys remember, when we are multiplying two quantities like this, we call them binomials because each of them have two terms. This is the way we multiply. Basically, you're doing distribution again. So you take the first term of the first expression and you multiply by the first term of the second expression. Then you take the first term of the first expression, you multiply by the second term. We call it rainbow. All right, so 3x times x, that gives us 3x squared. 3x times +2, that gives us 6x. Okay, so we finished distributing the first term. Now we want to distribute the second term. So we take the -4 multiplied by x, we take the -4 multiplied by 2. So there's the river. We got the rainbow and the river. Ha ha ha. Okay, so -4 times x gives you -4x. -4 times +2 gives you -8. Remember, negative times a positive is a negative. Okay. So combine like terms. There's no other x squared. So it's 3x squared. Then there is, these two are like terms. So I'm going to add these guys. They both have x's and powers of 1. So that's 6x minus 4x. So that's a +2x. 6 apples minus 4 apples. And the -8, I can't do anything with that. So there's the result of my multiplication. Is it in descending order? Yes, the expression is in descending order. The highest exponent is on the left, then the next highest, which is 1, which we don't show, and then the -8, which is your constant. So the degree is 2, the constant is -8, and the leading coefficient is 3. Okay, so let's do part D now. What does it say? What is the degree of each of the resulting polynomials? Well, we already talked about that. So in part A, the degree was 2. In part B, the degree was 2. In part C, all degrees are 2. Okay. What is the leading coefficient for each of the resulting polynomial? We already discussed that as well. In part A was -3, in part B was -3, in part C is +3. Okay, very good. I'm going to do the rest of these on this paper. Maybe it's easier. Okay, so. Sorry, I was going to get some water. Now, if you're simplifying these kind of expressions, we want to work from inside out and follow the order of operations. If you remember the order of operation, it was called, probably you remember PEMDAS, please excuse my dear Aunt Sally. Okay, but generally, well, P stands for parentheses, right? Then exponent, multiplication, division, addition, subtraction. But a better way of saying it is this, GEMDAS, where G stands for grouping symbols, because we don't, parentheses are not the only grouping symbols. We can have brackets that look like this, or brackets that look like this, so you can see all of those. Okay, so grouping symbols, exponents, multiplication, division, addition, subtraction. Now, when we get to multiplication and division, you don't always have to do multiplication first. Whichever comes between these two as you move from left to right in your expression, whichever comes, multiplication or division. And then you go to addition and subtraction, same thing. Whichever comes first as you move from left to right. You don't always have to do addition and then subtraction. Or you don't always have to do multiplication, then division. Whichever of these two come first as you move from left to right. Okay, and so you see now we have parentheses and brackets. All right, so let's start from inside out. Now, I can't do anything with x and -2. But what I can do is distribute this -3 inside, right? Zoom in a little bit. I can distribute that -3 inside. Now, I can't subtract 4 and 3 because -3 is being multiplied by that quantity in parentheses. So remember, order of operation. Parentheses come, I'm sorry, multiplication comes first before subtraction. So I can't subtract these two. So I'm going to rewrite 5x squared minus 3x times 4. Now distribute. -3 times x is -3x. -3 times -2. Negative times a negative is a positive. 3 times 2 is 6. There goes my parentheses. They're gone. Okay, now the next step, still we can simplify inside these grouping symbols, the brackets. So I'm going to write it. I can't do anything with -3, so I'm going to keep it like that, but I can add the 4 and the 6, so that gives me a 10. Okay, so I'm done with simplifying inside the brackets. I can't do anything else because these are not like terms, these two. So now I'm going to distribute, because you see this -3x is being multiplied by this quantity, so I'm going to distribute that. So I'm going to write 5x squared. Now, minus times a minus, that's a positive. 3 times 3 is a 9. X times x is an x squared. And then -3, the negative times a positive is a negative. 3 times 10 is 30, and x. Okay, so zoom out a little bit. Just, there we go. So do we have like terms? Yes, we do, because you see x and x, they're both squared, so I can combine these two. So what's 5 plus 9? 14. X squared minus 30x. And that's it. I can't combine these two because that's x to the power of 1, and that's 14x squared. Okay, let's jump to number 3, and then we'll come back to number 4. Oh, sorry. Yeah, that's the order. I forgot. I thought that was number 3. Okay. So if we do this, we distribute. Again, we're multiplying. So distribute the first. So 2 times 3 is 6. X times x, x squared. Then 2 times -4 is -8. X times y, it's just xy. Okay, so we are done distributing the first term. That's our rainbow. Now let's do the river. negative times a positive, that's a negative. 3x times y is just 3xy. When you have more than one variable, always put it in alphabetical order. It just makes it easier. And then negative times a negative is positive. There's a 1 there, so 1 times 4 is 4. Y times y is y squared. Do we have any like terms? Well, we have an x squared, no other x squared. We have y squared, no other y squared. So I'm going to keep those. But you see xy, xy. So these two are like terms. -8, -3. If they're both negative, just like if they're both positive, you add the numbers, but you keep the sign. So -8 minus -3 is -11xy, and then 4y squared. And voila, you're done. Okay, are we doing good? I hope so. All right, so let's do number 4. Now you see this x squared over there? That means this quantity is being multiplied by itself. So basically what you do, if you like, you can write it like this. So that's basically what it means, multiplying it by itself. So for example, if I have 2 squared, what does that mean? 2 times 2. Number multiplied by itself, or quantity multiplied by itself. So same thing, this was squared, so this times itself. So we do the same thing as number 3. We have first, so 3 times 3 is 9. X cubed times x cubed. What do? We add the exponents. Okay, so that gives us x to the 6th. And then multiply these two. Positive 3 times -2, that's -6. X cubed times y, so that's x cubed y. So we're done with that. Now we're going to distribute the second term. So we have -2 times a positive 3, that's -6. X cubed times y, x cubed y. Then negative times a negative, that's a positive. 2 times 2, that's a 4. Y times y is y to the 2nd power. Do we have any like terms? Yes, we do. We have, not this, that's x to the 6th, not that, but these guys. You see x to the 3rd y, x to the 3rd y. So we will have, I'm going to write it here, the 9x to the 6th. Now, what is -6 minus 6? That's -12x cubed y plus 4y squared. And there you go, you're done. Are we good? Okay, now let's talk about scientific notation. Now, scientific notation, let me write it over here first. Scientific notation it's written in this form. A times, that's times, not x, 10 to the power of n, where a is any number between 1 and 0. It could be a 0 itself. Okay. Now, what is scientific notation? Let's say you're an astronomer and you're doing certain calculations regarding Earth and the Sun, and the distance from the Earth and the Sun keeps popping up in your calculation, which is 150 million kilometers. Now, if you're doing calculation, this is kind of pain in the rear to keep using this number. This is called the standard form of a number, or decimal form. So we write it in scientific notation. How do we write it? Okay, here we go. Where is the decimal point right here? Well, if the decimal point is not shown, it's automatically at the end, right? What's the number to the left of the decimal point? Well, it's 150 million. Okay, I'm sorry, I wrote something wrong here. This should be a 10. Okay, so that's 150 million, right? So I'm going to move the decimal point until I get to a place where the number to its left is between 0 and 10. So I'm going to go 1, 2, 3. If I stop there, what's the number to the left of the decimal? 150,000. Still not between 0 and 10. 1, 2, 3. What's the number? 150. Still too big. 1, 2. If I stop here, what is that number? 1. Is that okay? Yes, it is. So 1.5. Oh, I'm sorry. Let me write it over here. So I'm going to write this in scientific notation in the following manner. 1.5 times 10 to the power. And now the power is the number of times you move the decimal. Not how many zeros you have. The number of times you move the decimal. How many times did you move the decimal? 1, 2, 3, 4, 5, 6, 7, 8. So there you go. That's the scientific notation format of that number, 1.5 times 10 to the 8 kilometers. It's the same thing, it's just in different format. Okay, now if you move the decimal to the right, then your exponent is negative. All right, so let's try number 9. It says write in scientific notation 0.0073. So what's the number to the left? Actually, I think I made a boo-boo here. This should have been a 1, not a 0. Sorry about that. 1, not a 0. So the number to the left of the decimal is 0. So I'm not going to have that. I'm going to move the decimal, but this time I have to move it to the right. So it's going to be 1, 2, 3. Now if I stop here, what's the number to the left of the decimal? That's 7. That's okay. That's between 1 and 10. So I'm going to write it as 7.3 times 10. How many times did I move the decimal? 1, 2, 3. But I moved it to the right, so I'm going to write it as -3. So when you have scientific notation with a negative exponent, then you're dealing with very small numbers. If you have a scientific notation with a positive exponent, then you're dealing with large